Okay, so welcome back to Mr. G's lab. Today we're going to be dealing with exact numbers, which is based off of significant figures. And so we're going to look at whether something is exact. Um, and basically, there's a few simple rules. So some numbers are exact, some numbers are not exact. Um, so Measurements are always approximate because you can have uncertainty in those measurements. And so Measurements are always approximate. So you would have to count the number of sig figs. So count sig figs. I'm just going to put SF. All right, and then some whole numbers are exact. So, for example, the number of doors in your room. You can't have 3.5 doors unless there's actually a half a door. So you would count the number of doors, the radius of a circle. Uh, um, so two times the radius of a circle equals the diameter. Um, 1 minute equals 60 seconds. 1 meter is 100 centimeters. So some numbers are exact and they have unlimited significant figures. So some conversion factors are exact and some are approximate. If you go from one set of units, such as metric, to English units, so kilograms to pounds, this is an approximation. So the 1, however, in that is a whole number with unlimited number of significant figures, but the 2.2 is approximate and has two significant figures. So that's one of those confusing parts we'll get into a little bit. Some whole numbers are not exact. So 110 volts can be 110 volts. It can also be 115 volts. It can also be 120 volts. It's all approximate. And so you have to count the number of sig figs. So in this case, it's 2, it's 3, and it's 2. So 2, 3, and 2. But all of them are the similar voltage that comes out of your electrical outlet. So, and you have to count the number of sig figs. So count sig figs. So weight is a measurement. So it is going to be approximate. So you have to count how many significant figures. So approximate. And it's going to be, we start counting from the first number to the last non-zero digit, from the first non-zero digit to the last non-zero digit, and that's going to be 2. So here we have 2 sig figs. 3, I'm not going to give you number 3. I'm not going to give you the answer, but this is exact. So look up here for where the exact ones are, and what you do with those. I'd suggest looking at number 2. Some whole numbers are exact. What do you do with those? So let's see. The 3 in the average, number 7. So the 3 in the average of 6.2, 5.7, and 8.4. Can you have an average if that 3 is a 2.9 or a 3.1? If not, if you can't have the exact same average as you can with 3, then it would be approximate. Number 9, sorry about that, made a typo. But number 9, the 5,280 in 1 mile equals 5,280. I've identified that it's exact. Number 11, I've identified that it's approximate. Number 10, it's approximate. This mark right here, this tilde, is approximate. That means approximately equal to. So you have to look at that based on yeah. on the different you have to look at the uh, the approximate and look at the rules that are stated above. So that concludes our very short class meeting. Want to remind everybody, if you come to the class meetings, which I'm gonna start pushing towards 9:30, so it gives you all more time to get up. Um, you don't have to do anything. I enter your score in. You don't have to turn in any notes. You don't have to do any test question. If you miss the class meeting, you do have to watch this. You have to take notes. You have to submit a test question. You have to submit your notes. It would be easier for you to just come to class meetings. So, um, if there's any questions, feel free to email me, text me, call me. For those students who are in my class, for those who are not, leave a message in the comments below and I will respond to you as quickly as possible. Peace.